My name is Abby Rader, and I would like to be a mentor for Chem 101. So I'm going to do a problem that has to do with some of the concepts from Chem 101. So the question is, the first ionization energy of CS, or cesium, is 0.376 megajoules per mole. For a single photon, what is the minimum wavelength of light that can ionize cesium? So the first thing to look at here is just ionization energy and defining what that means. So that just means the amount of energy that is required to remove the first, because it says first and we know that it's the first electron from an atom. And so we're also given in the ionization energy in megajoules per mole. And because it's in megajoules per mole and we know that we're trying to find a single photon, we know that at some point we're going to have to convert that from moles into just a single photon. Also, knowing what a photon is and how it is just a form of energy that we use, we can relate energy just to what a photon is. We also know that we are going from energy to wavelength. So knowing that energy is inversely proportional to wavelength through the formula E equals NhC over lambda, where E is the energy, N is just going to be the number of photons, which in this case is going to be 1 because we have a single photon. H is Planck's constant, which is 6.626 times 10 to the negative 34th joules seconds. And then C, which is just going to be the speed of light, so 2.998 times 10 to the 8th meters per second. And then, of course, the wavelength, which is going to be in meters, and the energy, which is going to be in joules. So looking at this first, the first thing I'm going to do is convert the ionization energy into a single photon rather than a mole, and also into joules because the energy here needs to be in joules. So knowing that, I'm going to say 0.376 megajoules for every 1 mole times 10 to the 6th joules in every 1 megajoule times 1 mole, which is equal to 6.022 times 10 to the 24th or 23rd photons. And so here the megajoules will cancel out, the moles will cancel out, and you're left with just joules per photon. So doing that all out, you get 6.24 times 10 to the negative 19th joules per photon. And then now that you know what the energy is for every one photon, you can use that in the formula as our energy with n equals 1. So 6.24 times 10 to the negative 19th joules per photon. So